Today's notes, we're going to talk about the area of a triangle, any triangle to be honest. And in the triangle areas that we're trying to find, we've seen them before. Normally we know that area is 1/2 base times height, but these are going to just be a little bit different. So in the figure that I have over here, the first thing I want to do is complete the two ratios that I have listed. So sine of angle A and sine of angle C. So in reference to angle A, this is your theta. So you're looking at this triangle over here. So I'm going to redraw that triangle. So over here, we're going to have the triangle as H, B, and A, and then we have C. So if we're referencing angle A here, we're going to reference angle A, which is theta, and the sine trig function is going to be opposite over hypotenuse. So opposite is H over C, which is the hypotenuse. If we're referencing for sine C, this is referencing this angle. So this angle here will be theta. So I'm going to redraw that triangle. This is C. We're going to have not B, because technically B is the entire length down here. So I'm not going to recopy B. I'm going to put A, H, and I'm going to put big B up here. Okay, so referencing this angle theta for C, opposite over our hypotenuse is going to be H over A. Okay, let's look at the next section. So the next section says that you need to solve those two equations that we have at the top for H. So I'm going to have sine of A is going to equal H over C. I need to solve for this H. And then sine of C is H over A. Again, I need to solve for that H. Whoops. So let's go ahead and solve for that H, for both of them. So for the first fraction over here, technically we could put this over 1 and then cross multiply, or you could just multiply both sides by C. Some people find it easier just to multiply both sides by C, so I'll do that. That's going to give me C times sine of A is going to equal H. And then for this guy over here, if I was going to isolate H, I would do the same thing. So either cross multiply or just multiply both sides by A. So A times sine of C is going to equal H. Okay, so these are the two values or the two equations that I found when I isolated H. Okay, using these two formulas, let's look at the next step. So the next step states, recall the formula for area of a triangle, like I mentioned at the beginning, 1/2 base times height. Now you need to create two equations substituting each of the H's that we just found. So this H and this H, we need to substitute them in. Okay, so I'm going to make two separate equations. The area of your triangle is 1/2 base times height. For this first one, I'm going to substitute in the first equation. So I'm just going to take that first H that I found, and I'm going to substitute it in here. So I'm going to rewrite this as the area of my triangle is going to be 1/2 times the base. In parentheses, I'm going to put C times sine of A. That's my new equation. From here, it said to do it for each. So I need to write two equations using each of the new H's. So over here, I'm going to rewrite A area of the triangle equals 1/2 base times height again. For that other H that I'm going to use the second equation that I just found for A and C. So for this guy here, I'm going to plug in area of my triangle is going to equal 1/2 the base times A, which is the lowercase a this time, and sine C, which is the angle this time, so your reference angle. The problem at the top, or the topic at the top of the page, says that we're going to find the area of any triangle that we have. So these two equations are going to be used to actually find those areas. There's actually one more equation. So take a second and look at what we have here. Can you guess that third equation? Well, based on the two area formulas that I have B and C for referencing big angle A, and then I have lowercase b, lowercase a, and this time I'm referencing angle C as my theta. What is the third equation probably going to be? So my last equation will be area of my triangle is going to equal 1/2. I'm going to use A and C, which are both of my sides for my triangle, times sine of big B. So that angle B we haven't seen before, so we need to make sure that we include at least one equation that has it. So these are my three equations that I'm going to need for area of my triangle. So for the first part here, it says given two sides and an included angle, so side, angle, side, the area of any triangle is going to be calculated by these formulas that we've just identified. Well, think about the makeup of that formula. we have half of what? Well, if you look at the half part, we're taking A and C, we're taking B and A, we're taking B and C, and we're technically multiplying those. So we're finding the product of any two sides, and we're going to times that by the sine, because that is my trig ratio, and we have sine for each of those. So that's going to be, in words, how I'm going to find out my area for my side angle side triangles. So as you see from this first page, the first type of area we're going to find is for side angle side. So for these questions down here, as much as I would love to do every single question, I'm not going to. Some of the questions will likely turn into homework, so I want to make sure that I don't go through every single type of question. I will go through these three, however, numbers 1, 4, and 7. Okay, let's take a look at question number 1. So for question number 1, it says find the area and round your answer to the nearest tenths place. I will give you a heads up. You will need a graphing calculator for this. So if you haven't grabbed a graphing calculator, pause the video now and get a graphing calculator. Okay, let's actually go through this. So the first thing I want to identify in order to find this area is, can I find it? Okay, well, normally you would use base times height. And usually when you're using base times height, you should usually have a 90-degree angle here. So that way you know that it actually can be calculated for your base and your height to actually find that area. For this problem here, it's not quite a 90-degree angle. So instead, I'm going to use the side angle side definition, which represents the three formulas that I highlighted at the top of the page. So we have a side, an included angle, and another side. So from this, I'm going to actually use the formula that we've identified from the top. So in this formula, since I have a side angle side, I'm going to make this 1/2 the two sides. And remember, AC, BC, and AB, those are the different letters we usually had for each of the formulas. Those are just two sides. So all of these, B, C, A, all of these that I'm circling, these are all sides of your triangle. The big A, big B, and big C, these are all angles of your triangle. So all we're going to do is we're going to take half of both of your sides of your triangle, and we're going to multiply it by sine of 87 in this case. Technically, if you wanted to, you could go ahead and try to simplify this, which isn't bad. I mean, 8 divided by 2 is going to give me 4. So technically, you'd have 4 times 6 times sine of 87. But keep in mind, your calculator is going to do all that work for you. So over here to the side, I'm going to bring over your calculator. And we're going to go into a brand new document. So we're going to go into option 1. Let me actually go back to the main page. Go into a new document. We're going to go to option 1, which is calculator. And we're going to make sure that our calculator is in degrees. If it's not in degree, go to document. Option 7, which is settings and status, and then hit option 2, which is document settings. You're going to change it from radians into degree. Since I don't have that problem, I'm going to recopy the 4 times 6. And you don't have to put it in parentheses. You could use the regular multiplication button times the sine of 87. So my area for my triangle is going to be 23.9671. I'm just recopying it on my page. So over here, if you think back to the directions, it told you to round to the nearest tenths place. So I'm going to round it to the nearest tenths place by making this the area of my triangle is approximately 24.0 centimeters squared. Don't forget your units, guys. This would be your answer. Go ahead and pause the video now and try to do example 4 and 7. For example 4, we're going to do the same thing, and this one's asking us again to find the area of your triangle. For this problem, it doesn't have a right angle, unfortunately, so I don't think I can use my area equals 1/2 base times height formula, but I do have a side, an included angle, and another side. So I can use the area of my triangle formula. So I can use the area of my triangle formula. Take half of both of your sides, multiply it by the sine of the angle that you already have, and then plug it into your calculator. So in your calculator, we're going to plug all of it in. I know I can take half of 4, but I don't want to waste time. So let's go ahead and plug this in. I'm going to make my fraction. We're going to do 1/2. And we're going to multiply that by 7. Whoops, let me actually delete that. put it next. So make sure you arrow over, guys, to get out of that denominator. We're going to multiply it by 7, by 4, and then we're also going to multiply it by sine of 96 degrees. This area is going to give me 13.9233. Okay, so let's go back to our screen over here. And if you notice, I forgot to put my little triangle symbol, so let me put my little triangle symbol. I need to round this to the nearest tens place. Okay, so when you're rounding it to the nearest tens place, you're looking at the space right next to the tenths place, which was the hundredths place. This 2 would normally, well, you would hope that it would round your answer up. But since 2 is below 5, it's not going to round your answer up. So the area of my triangle is going to be approximately 13.9 square inches. That's my answer. For example 7. For example 7, I am going to probably want to draw an actual representation of this. So over here to the side, I'm going to draw a triangle, and it's going to have 2 sides that have a measure of 5 centimeters and 8 centimeters with an included angle of 39 centimeters, or 39 degrees, excuse me. So I'm going to redraw my triangle. It doesn't matter what sides you label it. We can label it A, B, and C, especially since it doesn't give us specifics. You don't have to do this, but I do have a side that's going to be 5 centimeters, an included angle, which is going to be 39 degrees, and another side that's going to be 8. So you have to make it, it doesn't matter where you put it, but you want to make sure that this is going to be a side angle side. Both sides need to have an included angle. So from this side to this side, it needs to be included. Okay, so let's go ahead and use our area formula. So the area of my triangle is going to be 1/2 of both of my sides times sine of the angle measure that's given. So in your calculator, to make sure you did this correctly, we're going to type in 1/2. We're going to multiply it by 5 times 8. And then we'll, 5 times 8. And then we'll also multiply it by sine of 39 degrees. If you don't put that little multiplication symbol, it'll do it for you guys. I didn't do that on the last question, but I did do it for this one. So just be patient. Okay, so I have 12.5. So my area of my triangle is going to be approximately 12.5864. Move this back. And if I look at this, I would definitely want to round this to the nearest tenths place. So that's going to give me about 12.6 square centimeters. That's my answer. All you're doing for these questions, and I'll scroll this up in case you can't see, for all these questions for the area of any triangle, especially if you're using side angle side, the most important thing that you want to make sure that you do is that you just take half of both of your sides and use sine, not cosine, not tangent. Make sure you use sine. Okay, let's look at the next page. On the next page, this one is asking for you to use find the area of any triangle using the side, side, side notation. Okay, so let's think about that. If we have side, 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 that means that you have to have 3 sides given with no angle measures, as it says up here. Keep in mind, usually whenever you are trying to find the area of a triangle, you're usually given a triangle, and it has a base, and it has a height. That height is usually perpendicular to your denominator, or to your base, not the denominator, to your base. Or you'll be given a right triangle like this. This would be your base, this would be your height. For all of these questions, we don't have that. We can't find that height piece. So especially for these questions, we're going to use Heron's formula. Heron's formula is going to help us identify the area of your triangle when you're not given the base and the height. So there's 2 steps to this formula. The first thing you're going to do is find the semi-perimeter. The semi-perimeter is found by this equation. And then the second thing we're going to do is we're going to actually calculate the area using this formula. We're going to take half of the square root of your semi-perimeter. All of the S's represent your semi-perimeter. And then you're going to use the A, B, and C, which are the sides of your actual triangle. So we're just going to plug those in. I would love to do all of these questions with you, but we're at least going to do a few of them. So right now, over here to the side, let's look at example 2. So in example 2, the first part of this is going to be find the area for this triangle. Well, unfortunately for this triangle, I'm only given 3 sides, only the side lengths. I can't use the side angle side equation from the first page, those 3 equations where you take half of the side and use an angle that's given. Can't do that. We can't use the 1/2 base times height. So we're going to use the 2 equations that I've highlighted up here in yellow. We're going to use Heron's formula. So the first part of Heron's formula is to find your semi-perimeter. Your semi-perimeter is calculated by adding up your sides and then dividing them by 2. So in your calculator, I'm going to move this over. I'm going to make a fraction, and we're going to add 14 plus 14 plus 13, and we're going to divide that by 2. So this is going to give me 41.2, which is technically, if you wanted to make this into a decimal, you would need to go to number 2, which is number. Whoa, 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 back up, back up. Escape, escape. There we go. Let's try this again. Menu. Go down to option 2. And then it says convert to decimal. That's what I want to do. So convert to decimal, which is option number 1. And that's going to make it 20.5. It's probably going to be a lot easier for you to plug this in if it's a decimal. So let's go ahead and make it 20.5. The second part of this is to actually find the area. So the area for that triangle is going to equal the square root of. I'm going to use my semi-perimeter, which is 20.5, and I'm going to plug it in for every S that you see in this formula, including this first one here. You're going to take S minus A, which is the first side. It doesn't matter which side you use. You're just going to subtract all of them anyway. And then 20.5 minus the second side, and then 20.5 minus the last side. All of that is under your radical. I'm going to bring my calculator back over, and we're going to substitute this in. So we're going to take the square root of, we're going to do 20.5 parentheses, 20.5 minus 14. You're going to plug this in for all of them, guys. So make sure as you're writing this out or plugging this in that you actually use the parentheses button. And this is minus another 14. Close parentheses, open it, and we're going to do 20.5 minus 13. The last parentheses part here, you don't have to hit this button again unless you really want to. If you hit enter at this point, it'll populate that parentheses to end it. So right now, my area should be approximately 80.5974. Let's go back to the other page. And I have my area. Based on the directions that this problem told us, we need to round this to the nearest tenths place. So in the nearest tenths place over here, I'm going to approximate this to about 80.6. And this is in centimeters squared, so square centimeters. This is your answer. Pause the video now and try to do example 2. Pause the video now. No, excuse me, we already did 2. Try to do example 5. So problem number 5. For example number 5, this one is going to ask us to find the same thing. So in order to find the semi-perimeter for this triangle, I'm going to need to identify all my sides, find the semi-perimeter, and then find the area. So over here to the side, the first step that I'm going to do is find the semi-perimeter. I'm going to add up my sides. So I have the sides of 12, 16, and 11.9. And we're going to divide all of that by 2. So I'm not going to keep flipping back and forth to show you what the question is because hopefully you can see it on your page. Okay, I'm not going to keep pulling over the calculator either because, I mean, you guys should be able to identify this by now. So in your calculator, go ahead and calculate this. If you add up those numbers and then divide them, you should get about 19.95 for your answer. Okay, so the second part of this is to actually find the area for that triangle. So the area for that triangle, we're going to use the square root. And we're going to take all of the sides that we've previously labeled in the semi-perimeter, and we're going to substitute them in. Remember, your area formula is going to be a little long, so give yourself some space, and make sure you put parentheses around everything that needs it. So we're going to put in 19.95, and we're going to subtract that from 12. Subtract that from 16, and then 19.95 minus 11.9. Even though I didn't have space up here, I'm pretty much saying that that should be at the end of that piece. Okay, so in your calculator, let's go ahead and plug that in. We're going to do the square root, and I'm going to put 1995, 1995 again, minus 12, minus 16, and then 1995 minus 11.9. Be careful. It's very simple, but you can easily make mistakes if you're not paying attention. So the area for this triangle is going to be approximately 71, not 17.0152. Make sure your answer looks just like mine. So when I approximate this to the nearest tenths place, I'm going to make this 71.0. And this is going to be in kilometers. Yeah, square kilometers. That's my answer. So we've done pretty much a lot. We've identified, based on the problem that's given, if we have 3 sides, what can we do to find the area of a triangle? And on the last page, we saw if we have a side, an included angle, and another side, how you can find your area for your triangle. So pretty much for questions 1 through 10, those are a combination of those questions. Side, 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 angle, side. Technically question 11 as well. For questions 12 through 16, though, these are a little different. I also want to have you make a note that question 15 up here for angle B should be 16 degrees. And technically down here for question 10, this angle up here should be 20 degrees, so angle Z. Let's do one last question just to show you guys what you could do if you had a problem that you didn't really understand what to do. I said question 11 was side, angle, side, but I clearly wasn't looking at it better. This is actually not side, angle, side. So let's actually do question 11. So for question 11 over here, I'm going to identify first, what do I have? I have 2 angles and a side. The side is not in between the 2 angles. It's away from it. So, okay, that's not one of the 2 that we've talked about. What we need to do is try to make it like one of the questions we've seen before. So take a second and look at it. What can I do to try to solve this? Well, one thing that I want you to notice is that this problem here has 2 angles that are already inside of your triangle, but it's missing angle X. So the first thing we're going to do for problem 11, so I'm going to label this, let me do a different color. For question 11, the first thing I need to do is that missing side. So that missing side, which is angle X, I need to actually find that. So for angle X, I'm going to take 180 minus 111 minus 39, and I need to solve. That's going to give me my missing angle, which is angle X. Well, if you use the triangle sum theorem, which is technically what this is going to give me 30 degrees. That's going to be my angle measure for angle X. I need that. So here's 30 degrees. Okay, well, now that I found that, and this was by the triangle sum theorem, let's figure out what else we can do. Okay, well, if I look at the rest of this question, I actually have a side, or an angle, excuse me, and a side directly across from it. Yet, let's use law of sines to try to find my next piece. Because honestly, remember, guys, we need to try to use either side, 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 or side, angle, side in order to find our answer. Right now, I have only one side, which is a 6, and I don't have another side length here or another side length here. So let's go ahead and try to find that. So for this question, I'm going to use law of sines. Like I said, I'm going to do sine of 111 over 6 equals sine of 39 over, we'll say lowercase z, and sine of x, which is 30, over lowercase x. Okay, well, honestly, we have 2 unknowns. There's a couple things we could do here. If we wanted to, we could use Heron's formula, which means I would need to find the z value and the x value in order to identify or use the Heron's formula, which would be side, side, side. If I just find one of these other sides, I would be able to use the side, angle, side formula. It doesn't matter to me which one you use. It probably would be easier for us to use side, angle, side. So let's go ahead and find, we'll say x, because if I can find that side, I'll be able to find my answer. So let's use this equation and this one. I will let you know, on my answer key, I actually used Heron's formula, so you can use that one as well. So just kind of keep that in mind. So what I want you to do right now is pause the video and actually attempt question number 11. I'm going to pause it too, and when you unpause the video, it will have the actual answer worked out completely. So pause the video right now and work through the rest of question 11. So let's take a look at what we got. In purple, I actually did the cross multiplication for both of these fractions. So I cross multiplied. Once I cross multiplied, I used my calculator and I substituted this fraction in degree mode, and I got this answer. So x is the missing side length on your triangle. So x over here is 3.21343. Okay, technically there's more decimals, but we'll deal with that when we look at the calculator. If you look at the problem that we currently have now, this is why I was able to use the side angle side formula. Again, you can use Heron's if you want to, but then you would have to find this missing side over here, which will just take more time. So the reason why I can use side angle side is because I have this side, the included angle, and this side here. That's the main reason why I can use the side angle side method of area of a triangle, any triangle. So in my calculator, I'm going to take what I have down here in red, and I'm going to substitute this in. So in my calculator, I'm going to type in my 1/2. If you think back to last class, whenever we were multiplying by some number that we previously had found, we did the process of hitting control and then negative to get that answer. You can definitely use that on this question, but I want to give you another option in case you want to use later on. If you scroll back up to any of the other answers that you have, you can actually recopy that into this space. So especially since I just want that 3.2 to be copied down, I'm just going to hit enter. What that's going to do is it's going to recopy this value back down. The only reason why I don't always use this is because sometimes the items that I try to copy down, especially if it's in the denominator of a fraction, it might give you an issue. So be careful, but anytime you are trying to recopy something down, you can either use control negative or you can just scroll back up. Okay, continuing on, we're going to multiply this by 6, and then we're going to do the sine of 39 degrees. Okay, so that's going to give me my area of my triangle. It's going to be approximately 6.06684. So I'm going to go back to my page. So on my page, I did write this out. If you use Heron's formula, this might be a little different, a little bit off compared to what we currently have. However, the final answer, if you look back at the directions at the top of the page, specifically asks you to round to the nearest tenths place. Whether you do it using Heron's formula or the side angle side formula, you'll still get the exact same answer, which is the angle or the area of this triangle is going to be 6.1 meters squared, or square meters. Make sure that when you guys are solving these, try to make sure you keep writing the approximation when you get your answer. Throughout this document, I've kind of been sketchy with putting or not consistent, I'll say, with not putting the approximation symbol for everyone. But just make sure as you're writing it out, it should be approximately because we didn't include the entire decimal.